Hello, dear students. I am Rahul Chaturvedi. I am a physics expert, and in this video, we will be discussing a topic of class 11th physics, motion in a straight line. So let's start the session. So our topic is motion in a straight line. So motion in a straight line means actually motion in one dimension. So when we talk about motion, that motion can be in one dimension, two dimension, and it can also be in three dimension. When we talk about motion in one dimension, it is like any ball rolling on a plane. Suppose ball is rolling along the x direction. So we can say that motion of ball is one-dimensional motion. When we say motion along the two dimension, suppose you throw any ball at certain angle with the horizontal. Then the motion of the ball will be like a curvilinear path. And since it is a curvilinear path, we can say it is having horizontal as well as vertical motion. So its motion is along the x direction as well as along the y direction. So this kind of motion is two-dimensional motion. And three-dimensional motion is like motion of a plane during taking off and landing. Also, you can say motion of the birds. Is an example of three-dimensional motion. In your syllabus, you have to study motion along the 1D and motion along the 2D, right? This chapter deals with the motion along 1D. So in this chapter, we will discuss only one-dimensional motion, right? Now, in this chapter, we will cover topic like introduction, position vector, displacement and distance, average velocity, average speed, and average acceleration. Displacement, velocity, acceleration, time and their relations, horizontal motion, which is having constant acceleration, motion under gravity, motion with variable acceleration, and their graphs. So let's start. The first concept here is position and frame of reference. So position. When you say any object is in motion, suppose a man is walking on the ground with certain velocity v, and at time t is equal to 0, you are observing its position as x is equal to, suppose, 0. After certain time t, its position changes. Now its position is x is equal to 50 meter. After time 10 minutes. So we can say that this the position of this person is changing with respect to time, right? So since its position is changing with respect to ground, so here you have to consider the frame of reference as the ground, because ground, with respect to ground, he is moving, right? So here frame of reference will be ground, right? Take another example. Suppose there is any bus and bus is moving with certain velocity v, and there are two persons standing on this bus, Mr. X and Mr. Y. So with respect to bus, both x and y are stationary. Means with respect to bus, they are not moving, right? Their position is not changing with respect to time. But with respect to any other person who is standing outside the bus and he is stationary, he can observe that since bus is moving, so both x and y are also moving, right? So with respect to z, x and y are in motion. So when you say that position is changing, you have to consider the frame of reference. Okay, frame of reference is the frame where observer is actually placed. Where observer is placed, that is known as the frame of reference. So next, the basic concept here is distance or path length. So what is a distance? When you say any object is in motion, that means its position is changing with respect to time. Since its position is changing with respect to time, that means it is covering some distance. So distance is nothing but it is a total path length. So distance is a total path length. Suppose any person started its journey from point A and it is moving through some curved path. So from A via B, he reaches to some point C. So that A to B and then C, it is a what? It is total path. And its length is known as the distance. But if you say the person directly reaches to point C, means this is a shortest path. So A to C is actually will be the shortest path. And that shortest path is known as the displacement. Clear? So total path length is the distance and shortest path is a displacement. Clear? Now, as we know, displacement is a shortest path and distance is a total path length. That means we can say distance is either greater or equal to displacement. For example, any person is going in a straight line. That means it in this case, distance will be equal to displacement. And as we have seen in the previous case, that distance is greater than the displacement. So distance, you can say distance is always greater than or equal to mod of displacement. Now you may confuse that why we have taken mod. Mod means we are not considering the sign of displacement. Since displacement is a vector quantity, and distance is a scalar quantity. So what is a scalar and what is vector? A scalar means having only magnitude. And vector means having magnitude as well as direction. So magnitude means having only numerical value, and direction, it actually represents the sign. For example, if you say any person is moving 10 meter, so that 10 meter can be along any direction. But when you say it displaces towards plus 10 meter in the x direction, so you can say now its position is x is equal to plus 10. Or if you say x is equal to minus 10, then the position will be something else. So this will be x is equal to minus 10. Hope the difference between distance and displacement is clear to all of you. Now, the concept of speed started. That first you have to know what is the speed. Speed is actually distance traveled per unit time. So how much distance you are covering in a unit time, that is known as your speed, right? Its unit is meter per second, centimeter per second, or it can also be kilometer per hour as per the requirement of the question. Okay, so speed is distance upon time. Suppose you are going to a market. In that case, your speed is not uniform throughout your journey. Your speed is actually a variable. Sometimes your speed is high, and in the traffic area, your speed becomes low. So since speed is fluctuating during the whole journey, the concept of average speed comes into the picture. So for the whole journey, you have to take average speed. For average speed, the concept is average speed is total distance upon total time taken. This is a very basic formula, and you have to always use this formula for the calculation of average speed. So average speed is a total distance upon total time taken. It is a scalar quantity. Speed is a scalar quantity. So average speed is also a scalar quantity. Its unit are also meter per second, centimeter per second, and kilometer per hour. If I say 1 kilometer per hour, it can also be written as 1000 meter divided by 60 into 60 seconds. If you cancel two zeros and cancel 10 by 2, so 5 and 3. So finally you have 5 upon 6 into 3 means 18 meter per second. So this conversion is very important. 1 kilometer per hour is equal to 5 upon 18 meter per second. Right? Let's solve this question. A car travels from town A to town B at a speed of 40 km per hour and returns to town A at 80 km per hour. Find the average speed. So suppose the town A, here is town A, and at certain distance, there is town B. So from town A to town B, distance is S. So A to B, its speed is 40 km per hour. And while returning, its speed is 80 km per hour. You have to find out the average speed. For average speed, you have to take total distance upon total time. So here total distance, while he is going from A to B, he is covering distance S, and again from B to A, he is covering distance S. So total distance now is 2S. And total time, total time, suppose while going from A to B, he is taking time T1, and from B to A, he is taking time T2. So total time here is T1 plus T2. Since we know speed is equal to distance upon time, and time is equal to distance upon speed. So time T1 will be distance he is covering S with speed 40. And for T2, S upon 80. So this is what total time. You can take LCM of 40 and 80, which is 80. So this will be 2S plus S. So total time is nothing but 3S upon 80. Now you can put this value here. So this will be 2S upon 3S divided by 80. S will be cancelled, and finally you have 160 upon 3. So now average velocity is 160 upon 3 kilometer per hour. As the speeds are given in the unit of kilometer per hour, so average velocity will also be with the same unit, kilometer per hour, right? Next concept is average velocity. In the average speed, we have taken total distance upon total time taken. In average velocity, we will take displacement instead of distance. So average velocity will be total displacement upon total time taken. Total displacement, like if I'm considering XY coordinate plane, so suppose any person initially at point A, and after some time, it reaches to some other point B. The position vector of A is R1 vector, and position vector of B is R2 vector. So actually now the displacement will be AB vector. So displacement here will be AB vector, and this AB vector will be R2 vector minus R1 vector, right? So here average velocity will be equal to R2 vector minus R1 vector, means net displacement, and it is during time delta t, so divided by delta t. This will be your average velocity. Fine. Let's solve this question. A particle that covers half the distance with v1 speed and other half with v2 speed, find average speed. So this is a very important case. Here half the distance and another half the distance means distance are equal. So from A to B and then B to C, distance is S by 2, and again distance is S by 2, right? Initially speed is V1 and then speed will become V2. Means speed is not uniform throughout the journey. That means we have to consider the concept of average speed. Suppose during A to B, time taken was T1, and from B to C, time taken was T2, right? So time T1 will be equal to, as we know, speed is equal to distance upon time. So time will be equal to distance upon speed. So distance from A to B is S by 2 upon V1. So this will be S upon 2V1. Similarly, time T2 will be equal to S upon 2V2. For total time, you have to take T1 plus T2, and you can take S by 2 as a common, and this will be 1 upon V1 plus 1 upon V2, or S upon 2 V1 V2 multiply by V1 plus V2. So this is your total time, and total distance is again S by 2 plus S by 2. So this will be S. For finding out average speed, total distance S divided by S into V1 plus V2 divided by 2 V1 V2. S will be cancelled. And finally, you have average speed is equal to 2 V1 V2 divided by V1 plus V2. You have to remember this formula. This is a very important formula. Next question, a particle that travels half the time with V1 speed and other half with V2 speed. So here we are equating time. So in equal interval of time, speed is actually changing. So solving this question, now time is equal. So V1 speed from A to B and V2 speed from B to C, right? Here time is T by 2 and again time is T by 2. Distance will be having some different value, S1 and S2. So you have to find out actually S1. So distance is equal to speed into time. So here speed is V1 and time is T by 2. Again, S2 is equal to V2 into T by 2. Total distance S will be S1 plus S2 and this will be equal to T by 2 into V1 plus V2. Total time here is T by 2 plus T by 2 and this is equal to again T. So finally, for average speed, you have to take total distance upon total time. So this will be T by 2 into V1 plus V2 divided by T. T will be cancelled out and finally you will have V1 plus V2 by 2. This is your average speed, right? So this is a very important question from Erodo. Let's solve this question. A man half the distance with a velocity v0. The remaining part of the distance was covered with velocity v1 for half the time and with velocity v2 for other half the time. Find the average speed of the man over the whole time of motion. So here actually distance is half and for that half distance speed is v0 and for remaining half distance the velocity is v1 for half the time and for another half the time velocity is v2. Let's solve this case. Distance is s by 2. Here velocity is v0. Right? For remaining half, velocity is v1. Suppose here in the first half, time taken is t1. For the remaining half, time taken will be t2. And for this part, time taken will be t2 by 2. Again, this will be velocity will be v2 and time taken will be t2 by 2. Right? So A, B, C and D. Right? This distance is S1 and from C to D, distance is S2. Right? And S1 plus S2 is what? S1 plus S2 will be S by 2. So I'm mentioning here as S1 plus S2 is equal to S by 2. S1, can we find out S1? So S1 means distance which will be equal to speed into time. So this will be V1 into T2 by 2. And S2, again, this will be equal to V2 into T2 by 2. And for S1 plus S2, we will have V1 plus V2 into T2 by 2. This will be equal to S by 2, right? 2 will be cancelled, and T2 will be equal to S upon V1 plus V2, right? Now we have T2. We have value of T2. We have to find out T1. So T1, again, time is equal to distance upon speed. So distance for the first half will be S by 2 and speed is V naught. Now you have T1 and T2. Now you can use the formula of average speed, which is V average is equal to total distance. Here total distance is S and total time will be T1 plus T2. So we can directly put the value S upon 2V naught plus S upon V1 plus V2. So S will be common and you will have 1 upon 2V naught plus 1 upon V1 plus V2. S will be cancelled. And finally, we will have V average will be equal to 2V naught times V1 plus V2 divided by 2V naught plus V1 plus V2. This is how we can find out average velocity, average speed actually. So our next part is a car runs at a speed on a circular track of 100 meter. So there is circular track of radius 100 meter and taking 62.8 seconds for every circular lap. The average velocity and average speed for each circular lap respectively is. So since motion is along the circular lap, suppose started from point A and again reaches to point A, right? So since total displacement will be 0, since initial and final point is equal or same, so displacement will be equal to 0 and distance covered will be equal to 2 pi r. So 2 into 3.14 and radius of this circle is 100 meter, right? Time is already given as 62.8 seconds. So average speed will be equal to total distance upon total time. So total distance is 2 into 3.14 into 100 divided by 62.8. So this will be equal to 10 meter per second. And for average velocity, you have to consider displacement upon time. So displacement is 0 and time is again t. So this value will be 0. So average velocity will be 0 and average speed will be 10 meter per second. Answer will be B option. So friends, our next topic will be average acceleration. So in future session, we will cover average acceleration. So thanks for watching. All the best.